Gas flow. In this module, we will talk about gas flow in the anesthesia machine. The hospital medical gas pipeline source is the primary source for the anesthesia gas machine. This may be provided by a central distribution system or by pressurized tanks or cylinders. The pipeline gases go to the manifold, which is considered the heart of the machine. The manifold is responsible for routing incoming gases to the appropriate parts of the machine. The primary components of the manifold are pipeline inlets, gas routing connections, high-pressure relief valve, oxygen flush regulator, and the oxygen power outlet. Pipeline inlet. The hospital pipeline contains a transducer that regulates the pressure to 50 to 55 pounds per square inch, which is the normal working pressure of most anesthesia machines. All of the gases used by the anesthesia machine, such as oxygen, nitrous oxide, and air, are delivered to the operating room through the pipeline inlet. The pipeline inlet has color-coded tubing which connects to the machine through the DIS, or Diameter Index Safety System. The DIS prevents incorrect hose attachment to the machine. Once the hoses are correctly connected to the machine, there is a filter that helps trap debris from the wall supply to prevent it from entering the machine and causing problems with the pipeline source. Distal to the filter, there is a one-way check valve that prevents flow from going back into the pipeline source. The oxygen pneumatic power outlet is used to drive the ventilator and power the auxiliary oxygen flow meter. This is the cylinder inlet. The cylinder inlet is considered the high-pressure circuit and consists of those parts which receive gas at cylinder pressure. The cylinders attached to the machine by the yoke assembly. The components of the yoke assembly include the hanger yoke, which orients the cylinder, provides unidirectional flow, and ensures a gas-tight seal, a washer and gas filter, which filters debris from the cylinder, and a check valve that minimizes transfilling, allows changing of a cylinder during use, and minimizes leaks to the atmosphere if the yoke is empty. The Pin Index Safety System, PIS, also part of the hanger yoke, prevents misconnection of a cylinder to the wrong yoke. The PIS system has two holes in its cylinder valve that connect with corresponding pins in the yoke of the anesthesia machine. The specific positioning of the pins and holes corresponds to a specific gas. The oxygen pin index is at 2 and 5, and nitrous oxide is at 3 and 5. The cylinders that are connected to the yoke assembly are oxygen, nitrous oxide, and air. The cylinders that connect to the yoke assembly are oxygen, nitrous oxide, and air. The standards for cylinders are written by the U.S. Department of Transportation, the DOT, the Compressed Gas Association, the National Fire Protection Association, and the American Society of Mechanical Engineers. These cylinders are marked with DOT, service pressure, serial number, commercial design, inspection date, and inspector's mark. The cylinders are usually inspected every 10 years and can be identified by the capacity, color, and markings on the cylinder. Primary regulator. The high variable cylinder pressure is reduced to a constant pressure by the pressure regulator to approximately 45 to 47 psi before entering the flow valve. These regulators are also called primary regulators because they are the first regulators the gas encounters when flowing through the machine. The regulator consists of a diaphragm and a spring that senses the gas pressure from the cylinder to make the necessary adjustments to keep the pressure constant. The pressure of 45 to 47 pounds per square inch is intentionally lower than the pipeline pressure of 50 psi to prevent the silent depletion of the cylinder contents if the cylinder is left open. The pressure of the cylinder is measured using a bourdon gauge. This gauge contains a tube inside that, when exposed to gas pressure, straightens and causes the needle point to move, and the pressure can be read. Secondary regulator. Some machines are equipped with a secondary regulator that drops the pressure of the pipeline and the cylinder pressure even further. For example, the oxygen is further reduced to 20 psi and the nitrous oxide to 38 psi. These additional pressure reductions are needed for proper functioning of the linkage system. The secondary regulator is on most Datex Omidas machines and may also be needed for auxiliary oxygen flow meter, the oxygen flush mechanism, which delivers oxygen at high pressure of 35 to 75 liters per minute, and the drive gas to power the pneumatic ventilator. There are two sets of pressure gauges on the anesthesia machine, one for primary gases, which are the gases from the pipeline located under the flow meters, and one for the secondary gases, which are the gases from the cylinders. These gauges can be differentiated from one another because the gauge that shows cylinder pressure has a cylinder symbol on the gauge. There are also two sets of numbers on the pressure gauges. The large outer numbers are measured in kilopascals, and the inner smaller numbers are measured in pounds per square inch. Oxygen flow through the machine. Oxygen, the most important gas, is stored as a compressed gas at room temperature or refrigerated as a liquid. Once in the manifold, oxygen is the gas which is directed to the most number of places. Once the machine is turned on, oxygen goes to the flow meter assembly, and the oxygen concentration is measured before mixing with other gases, to the vaporizer, and exits the common gas outlet, and ultimately to the patient. Flow meter. There are two types of flow meters: constant pressure variable orifice or electronic. The anesthesia machines used at KU have the variable orifice, in which the ball, bobbin, or float is supported by the flow of oxygen through a tube, known as the Thorpe tube. Each flow meter assembly consists of a flow tube, float, flow tube filter, and float stops. To get the measurement of oxygen and all other gases that flow through the anesthesia machine, the knob is turned counterclockwise. The needle valve moves from its locked position, and gas is allowed to flow through the valve. The Thorpe tube has a tapered orifice at the end. This allows the gas flow to create pressure in the tube and allow the float to rise. The tube widens as it goes up, and more gas is allowed to pass around the float. To read the amount of flow, the bobbin is read at the flat top of the float, and if the float is round, it is read in the center. The knobs on the flow meter are color-coded and structured differently from one another to prevent turning on the wrong gas when it cannot be seen. For example, the oxygen knob is fluted and larger and protrudes out further than the other knobs, and is positioned furthest to the right of the machine. Also, in case a leak should develop from the oxygen flow meter, a hypoxic mixture could be delivered to the patient. To prevent this, the oxygen flow meters are always positioned downstream to all other flow meters. The Link 25 proportioning system is another safety feature of the flow meter. This safety feature is designed to minimize the chance of delivering a hypoxic mixture to the patient by maintaining 25% oxygen in the fresh gas supply. This is how it works. There is a chain linking system that links oxygen and nitrous oxide together. When the nitrous oxide knob is turned to open the valve, a sprocket drives the linking chain to turn the oxygen on as well. This feature is automatic and does not have to be turned on by the provider. This feature is also activated if the oxygen flow is turned down. The chain link will decrease the nitrous oxide flow to maintain a sufficient percentage of oxygen. The overall goal of this linking system is, when the nitrous oxide is more than 3 times the oxygen flow, or 30%, the oxygen is open to at least 25% of the overall mixture. If these two systems do not engage with each other, the oxygen, nitrous oxide, and oxygen flow valves operate independently of each other. The oxygen flush button. This button is designed to replace anesthetic gases or mixtures in the breathing circuit with oxygen when the patient needs 100% oxygen. Before being delivered to the breathing circuit, the oxygen pressure is reduced further by an oxygen flush regulator. This regulator reduces the supply pressure from 50 psi, which guarantees that pressure stays constant regardless of increases or decreases in supply pressure. The oxygen that goes through the oxygen flush button does not go through the vaporizer, so it significantly dilutes anesthetic gas mixtures. The oxygen flush button is also used to deliver high-flow oxygen, 35 to 75 liters per minute, and it also inflates the bellows and the patient breathing bag. This button is always operational when oxygen supply is connected to the system, even when the system switch is in the standby or off position. Oxygen also travels to the ventilator where it is used as the drive gas to pneumatically power some of its components. Oxygen also flows to the optional power outlet, which is located on the back of the machine. Equipment can be connected here if it requires pneumatic power, as used with the ventilator or auxiliary oxygen flow meter. Oxygen from this outlet is supplied at the same pressure as pipeline oxygen source. There are no regulators here. Oxygen is already regulated from the hospital supply source. Oxygen is also supplied to the system switch, and when turned on, it goes to the flow assembly, and the provider is allowed to adjust the amount of oxygen that is delivered to the patient. Airflow through the anesthesia machine. Another important gas used by the anesthesia machine is air. Air goes through the low-pressure side of the machine and also encounters a secondary regulator. Air also goes to the flow assembly and can be measured and delivered to the patient, and like oxygen, air travels to the system switch and can always be delivered to the patient even when the system switch is in the standby position. Air is the only gas that can reach the breathing circuit without sufficient oxygen pressure present. Nitrous oxide flow through the anesthesia machine. Nitrous oxide is also used by the anesthesia machine and only has one additional connection, directly to the flow assembly. When traveling through the anesthesia machine, gases such as nitrous oxide, heliox, and carbon dioxide encounter balanced regulators to prevent toxicity in the absence of oxygen. These regulators partially or fully block the passage of non-life-sustaining gases to their flow controls when oxygen pressure is insufficient or absent. This ensures that oxygen is the last gas flowing from the machine if there is a loss of oxygen supply. The balanced regulator for nitrous oxide closes completely when oxygen pressure drops to 0.5 psi. The balanced regulator for heliox and carbon dioxide closes off when the oxygen pressure drops below 10 psi. This concludes the module on gas flow in the anesthesia machine.